Reaching for the stars, a timeless dream. Since the dawn of humanity, we have gazed up at the stars and wondered about our place in the cosmos. The twinkling lights scattered across the night sky have sparked countless myths and legends, fueling our dreams of exploring the universe. For centuries, the vast distances between us and the stars seemed insurmountable. Yet the human spirit, driven by an insatiable thirst for knowledge and adventure, refused to be confined to our pale blue dot. The dream of reaching the stars has captivated the minds of scientists, engineers, and dreamers alike. But is faster-than-light travel truly possible, or is it destined to remain forever in the realm of fantasy? As we stand on the cusp of new scientific breakthroughs, the possibility of interstellar travel is slowly coming into focus. The cosmic speed limit, the tyranny of light speed. Our current understanding of physics, as described by Einstein's theory of relativity, suggests that faster-than-light travel is impossible. Einstein's groundbreaking work revolutionized our understanding of space and time. His theory states that the speed of light in a vacuum is the ultimate speed limit in the universe. This cosmic speed limit is a fundamental law of nature that governs the very fabric of space-time. According to Einstein's theory, as an object approaches the speed of light, its mass increases infinitely. This increase in mass has been experimentally verified countless times in particle accelerators around the world. The energy required to accelerate it further approaches infinity, making it physically impossible to reach the speed of light. Warping reality, bending the fabric of space and time. However, the pursuit of faster-than-light travel has not been abandoned. Scientists and science fiction writers alike have long been fascinated by the idea of warping space-time. Instead of trying to outrun a beam of light, what if we could manipulate the very fabric of space-time, creating shortcuts? Imagine, instead of trying to move through space at impossible speeds, we could fold space itself, bringing distant stars within reach. Think of a piece of paper with two dots on opposite ends, representing two distant points in space. Normally, to travel between these points, you would have to traverse the entire length of the paper. But what if you could fold the paper in half, bringing the two dots together? This, in essence, is the idea behind a warp drive. Instead of traveling through space, a warp drive would create a bubble of space-time around the spacecraft, compressing space in front of it and expanding space behind it. Alcubierre's dream, surfing the waves of space-time. In 1994, a Mexican physicist named Miguel Alcubierre proposed a theoretical model for a warp drive. Alcubierre's model, based on Einstein's field equations, offered a glimpse into the possibility of faster-than-light travel. Alcubierre's warp drive relies on the creation of a warp bubble, a region of spacetime that is contracted in front of the spacecraft and expanded behind it. This distortion of spacetime would create a local region where the spacecraft is essentially stationary within the warp bubble. Imagine a surfer riding a wave. The surfer doesn't move through the water as much as they are carried along by the wave itself. Similarly, a spacecraft using an Alcubierre drive wouldn't be moving through space in the conventional sense, but would be propelled by the warping of spacetime around it. One of the biggest hurdles is the requirement for exotic matter, a hypothetical type of matter with negative mass energy density. While negative mass energy density is not explicitly forbidden by the laws of physics, its existence has never been proven. The energy barrier powering a warp drive. Even if we could find or create exotic matter, the energy requirements for a warp drive are staggering. Initial calculations suggested that creating an Alcubierre warp bubble would require an amount of energy equivalent to the mass energy of Jupiter. However, subsequent research has offered some hope, with some physicists proposing that the energy requirements could be significantly reduced. While these revised calculations offer a glimmer of possibility, the energy barrier remains a formidable obstacle. Harnessing and manipulating such vast amounts of energy would require revolutionary advancements in our understanding of physics and engineering. A wrinkle in time, navigating the paradox of time travel. The prospect of faster-than-light travel also raises intriguing questions about time travel and its implications. Einstein's theory of relativity suggests that time is not absolute, but is relative to the observer's frame of reference. This means that time can pass at different rates for observers who are moving at different speeds, or experiencing different gravitational fields. One of the most perplexing consequences of faster-than-light travel is the possibility of time dilation. where time slows down for a traveler moving at relativistic speeds compared to a stationary observer. This means that a traveler embarking on a round-trip journey at speeds approaching the speed of light would age slower than people back on Earth. Upon their return, the traveler might find that years, decades, or even centuries have passed on Earth, while they have only aged a few years. The unknown frontier ethical considerations of FTL travel. Beyond the scientific and technological challenges, the prospect of faster-than-light travel also raises profound ethical and philosophical questions. If we were to develop the capability to travel between stars, what impact would it have on our understanding of our place in the universe? The ability to traverse vast distances and potentially interact with other intelligent life forms would undoubtedly have a profound impact on our society, our values, and our very sense of identity. Furthermore, the development of faster-than-light travel would raise ethical concerns about the potential for exploitation, conflict, and unintended consequences. From dreams to reality, charting the course of technological progress. While the challenges of faster-than-light travel are immense, history has taught us that what seems impossible in one era can become reality in the next. Consider the Wright brothers' first flight at Kitty Hawk in 1903. At the time, the idea of heavier-than-air flight seemed like a distant dream. Yet, within a few decades, airplanes transformed transportation, connecting continents and shrinking the world. The same can be said for space exploration. In the early 20th century, the idea of sending humans into space seemed like science fiction. Yet, within a few generations, we witnessed the first human spaceflight, the first steps on the moon, and the construction of the International Space Station. The power of imagination, fueling the engines of discovery. The pursuit of faster-than-light travel is not merely a scientific endeavor, it is a testament to the power of human curiosity, imagination, and our unyielding desire to explore the universe. Albert Einstein once said, "Imagination is more important than knowledge." It is through imagination that we envision new possibilities, challenge existing paradigms, and push the boundaries of human knowledge. The concept of warp drives and faster-than-light travel may seem like the stuff of science fiction, but it is through the exploration of such seemingly impossible ideas that we often make the most groundbreaking scientific discoveries. By daring to dream the impossible, we open our minds to new possibilities and pave the way for future generations to achieve what we once thought unattainable. A future among the stars, possibilities, and promises of warp drive. The development of faster-than-light travel would have profound implications for humanity and our future among the stars. It would allow us to explore the galaxy, establish colonies on distant planets, and potentially interact with other intelligent life forms. Imagine a future where interstellar travel is commonplace, where we can journey to other star systems just as easily as we travel between continents today. We could explore exotic planets, study distant stars up close, and unlock the secrets of the cosmos. The ability to travel between stars would also open up new opportunities for human expansion and settlement. Faced with the challenges of overpopulation, resource depletion, and climate change on Earth, humanity could look to the stars for new homes and a fresh start. Furthermore, the discovery of other intelligent life forms would have a profound impact on our understanding of our place in the universe. Conclusion: a universe of possibilities awaits. The quest for faster-than-light travel is a journey into the unknown, a pursuit fraught with challenges and uncertainties, yet it is a journey worth taking, for it holds the promise of unlocking the secrets of the universe and expanding the horizons of human potential. While we may not have all the answers today, the pursuit of this dream continues to inspire scientists, engineers, and dreamers alike. Through our collective ingenuity, perseverance, and unwavering belief in the power of human potential, we may one day unlock the secrets of faster-than-light travel and embark on a new era of exploration and discovery among the stars. For centuries we have gazed at the stars, our eyes filled with wonder and curiosity. The night sky, a canvas of twinkling lights, has always beckoned us to explore its mysteries. They twinkle, distant and alluring, each one a beacon of the unknown, a reminder of the vastness of the universe. We have dreamed of reaching out, of touching the cosmos, of stepping beyond the confines of our world and into the great expanse. What lies beyond our planet? What secrets does the universe hold, waiting to be discovered by those brave enough to venture into the unknown? What wonders await us in the vast expanse of space? From the swirling nebulae to the distant galaxies, the universe is a treasure trove of marvels. Today we stand on the cusp of a new era, one where the seemingly impossible might be within reach, faster than light travel. This is not just a dream but a potential reality that could redefine our place in the cosmos. Imagine a future where we are no longer bound by the constraints of conventional propulsion, where the limitations of time and distance fade away. A future where interstellar travel is as commonplace as a flight across the globe. This is the promise of warp drive, a theoretical concept that has captured the imaginations of scientists, writers, and dreamers alike. It is a concept that bridges the gap between science fiction and science fact. Warp drive, as envisioned by physicists, operates on the principle of distorting the fabric of spacetime itself. It is a revolutionary idea that challenges our understanding of the universe. Think of spacetime as a giant sheet, a vast, flexible fabric that can be manipulated and shaped. Now imagine placing a heavy object in the center. The sheet curves around the object, creating a dip, a distortion in the fabric. The sheet curves around the object, creating a dip. This is the essence of how gravity works, and it is the foundation upon which warp drive is built. Warp drive aims to create a similar dip in spacetime around a spacecraft. By manipulating the fabric of spacetime, the spacecraft can move in ways that defy conventional physics. By compressing the space in front of it and expanding the space behind it, the spacecraft could essentially ride a wave, propelled forward at incredible speeds. This method of travel could revolutionize our ability to explore the universe. While still in the realm of theoretical physics, the concept of warp drive is no longer relegated to science fiction. It is a serious subject of scientific inquiry, with researchers dedicated to turning this dream into reality. Scientists are actively researching and refining the mathematics and physics behind it. They are exploring the possibilities and challenges, pushing the boundaries of our knowledge. The challenges are immense, requiring advancements in our understanding of exotic matter and energy manipulation. These are not small hurdles, but they are not insurmountable. Yet, the potential rewards are even greater. The ability to travel to distant star systems, to explore new worlds, to uncover the mysteries of the universe, is a prize worth striving for. Warp drive holds the key to unlocking the cosmos, to venturing beyond our solar system and into the depths of the universe. It is a vision of the future that inspires us to dream big and reach for the stars. The human body, a marvel of evolution finely tuned for life on Earth. Over millions of years, our bodies have adapted to the specific conditions of our planet, from the pull of gravity to the composition of our atmosphere. Every cell, every organ, every system within us is optimized for terrestrial life. But what happens when we leave the familiar embrace of gravity, the protective shield of our atmosphere? The journey into space, while awe-inspiring, presents a myriad of challenges that test the limits of human resilience. Space, for all its beauty, is a harsh and unforgiving environment. The vastness of the cosmos, with its extreme temperatures, vacuum, and radiation, is not a place where life as we know it can easily thrive. Long-duration space travel poses significant challenges to human physiology. The absence of gravity, or microgravity, affects our bodies in ways that we are still striving to fully understand. One of the most immediate effects of prolonged weightlessness is muscle atrophy and bone density loss. Our muscles, which are used to working against gravity, begin to weaken when they no longer have to support our weight. Without the constant pull of gravity, our muscles, accustomed to supporting our weight, begin to weaken. This weakening can lead to significant loss of muscle mass and strength, making it difficult for astronauts to perform even simple tasks. Bones, no longer subjected to the stress of bearing our bodies, lose calcium and become brittle. This loss of bone density can increase the risk of fractures and other injuries both in space and upon return to Earth. Astronauts on long-duration missions engage in rigorous exercise routines to counteract these effects, but the challenge remains. Specialized equipment such as resistance bands and treadmills are used to simulate the effects of gravity and help maintain muscle and bone health. Radiation exposure is another significant concern. In space, astronauts are exposed to higher levels of cosmic rays and solar radiation than on Earth. Earth's atmosphere and magnetic field protect us from the constant bombardment of cosmic rays and solar flares. These natural shields deflect and absorb much of the harmful radiation that would otherwise reach the surface. In space, we lose this vital shield. The lack of atmospheric and magnetic protection means that astronauts are at a higher risk of radiation exposure, which can have serious health consequences. Exposure to high levels of radiation can damage cells, increase the risk of cancer, and affect the central nervous system. The long-term effects of this exposure are still being studied, but it is clear that radiation poses a significant threat to human health in space. While spacecraft shielding can mitigate some of the risks, prolonged space travel necessitates advancements in radiation protection technologies. Researchers are exploring new materials and designs to better protect astronauts from the dangers of space radiation, ensuring their safety on long-duration missions. Space travel is not only a physical journey, but a profound psychological one. The vastness of space, the unknown, and the sheer distance from Earth create a unique mental landscape that astronauts must navigate. The isolation and confinement of a spacecraft, where every inch of space is meticulously planned and utilized, can feel incredibly restrictive. The lack of personal space and privacy can amplify feelings of claustrophobia and stress. The lack of familiar sensory input, such as the sounds of nature or the feel of a breeze, can make the environment feel sterile and alien. Virtual reality technology is sometimes used to simulate Earth-like environments, providing a temporary escape. The constant awareness of the risks involved, from technical malfunctions to the threat of space debris, can create a persistent undercurrent of anxiety. Even the most well-adjusted individuals can find this mental load challenging. Humans are social creatures hardwired for connection and interaction. The need for social bonds is deeply ingrained in our psyche, and the limited social interactions in space can feel insufficient. The confinement of a spacecraft, even with a small crew, can lead to feelings of isolation, loneliness, and depression. The lack of new social interactions and the repetitive nature of daily routines can exacerbate these feelings. The lack of natural light cycles and the disruption of circadian rhythms can further exacerbate these effects, impacting sleep patterns, mood, and cognitive function. Astronauts often struggle with insomnia and irregular sleep, which can affect their performance. The psychological pressures of long-duration space travel are compounded by the constant awareness of the risks involved. Every spacewalk, every mission task, carries inherent dangers that require constant vigilance. Astronauts must contend with the knowledge that they are far from home, operating in a hostile environment where even a minor technical malfunction could have catastrophic consequences. This awareness can create a sense of vulnerability and stress. This constant stress can lead to anxiety, insomnia, and difficulty concentrating. The mental strain of maintaining peak performance in such an environment is immense. Selecting astronauts with the right psychological profile is crucial. They must possess resilience, adaptability, and the ability to remain calm under pressure. Psychological testing helps identify these traits. Providing them with extensive pre-flight training and in-flight support is essential. This includes simulations of potential scenarios, stress management techniques, and continuous communication with support teams on Earth. Fostering a strong sense of camaraderie and purpose among the crew is essential for mitigating these risks. Celebrating successes, no matter how small, and maintaining a positive group dynamic can help sustain morale and mental health during the mission. Venturing into the cosmos requires more than just a powerful spacecraft. It demands the creation of a self-sustaining ecosystem, a miniature version of Earth capable of supporting human life for extended periods. Food, water, and oxygen, the very essentials of life, become precious commodities in the void of space. Traditional methods of resupply from Earth become impractical or impossible for long-duration missions. Advanced life support systems are essential, capable of recycling waste products, growing food, and generating oxygen. Imagine a spacecraft transformed into a bioregenerative life support system, a closed-loop ecosystem where plants scrub the air providing oxygen and food, while waste products are recycled into nutrients. This is not science fiction, but an active area of research, essential for enabling long-duration space travel. Water, the elixir of life, is another critical resource. Recycling wastewater, even perspiration and urine, becomes essential. Advanced filtration systems and water reclamation technologies are crucial for ensuring a sustainable supply of clean water. The challenges of life support in space are complex and multifaceted, requiring innovations in engineering, biology, and chemistry. practical necessities and the boundless aspirations that define us. The journey to the stars is not just a technological challenge, but a test of our humanity. Warp drive, a theoretical concept that has captured the imaginations of physicists and science fiction enthusiasts alike, proposes a method for faster-than-light travel. Imagine a spacecraft capable of warping the fabric of space-time, creating a bubble that allows it to traverse vast cosmic distances at speeds exceeding the speed of light. This technology, if realized, would shatter the barriers of time and distance that currently confine us to our solar system. It would open up a universe teeming with possibilities, offering humanity a chance to explore new worlds, encounter alien life, and unravel the mysteries of the cosmos. The prospect of warp drive technology raises a sobering question. Will access to the stars be determined by wealth? History teaches us that advancements often benefit the privileged few before trickling down to the masses. Imagine a future where ultra-wealthy individuals secure their passage on luxury interstellar liners, leaving the rest of humanity earthbound. This scenario presents a dystopian vision of space exploration, one where the cosmos becomes another playground for the elite. It challenges us to envision a future where space travel is not a luxury, but a right, accessible to all, regardless of socioeconomic status. The development of warp drive technology would necessitate a complete reimagining of governance and international cooperation. Who would have the authority to regulate interstellar travel? Would it be individual nations, international organizations, or perhaps a new global entity specifically created to oversee space exploration? The stakes would be incredibly high. Control over warp drive technology would equate to control over access to resources, potential colonization sites, and perhaps even contact with extraterrestrial civilizations. The need for a fair, transparent, and globally representative system of governance would be paramount. Section 5. A Journey for the Worthy. The complexities of merit-based selection. One school of thought suggests that space travelers should be selected based on merit. This approach would prioritize individuals with specific skills, knowledge, and psychological resilience deemed essential for interstellar missions. Scientists, engineers, medical professionals, and perhaps even artists and philosophers could be among those considered most fit for the journey. While merit-based selection might seem appealing at first glance, it raises several ethical concerns. Who defines merit in this context? What criteria are used to measure an individual's worthiness? And how do we guard against implicit bias in the selection process, ensuring that opportunities for space travel are truly equitable? The concept of merit itself is multifaceted and can be influenced by various factors, including cultural, social, and economic backgrounds. Additionally, the dynamic nature of space missions requires a diverse set of skills and perspectives, which may not always align with traditional definitions of merit. It's crucial to consider how different experiences and viewpoints can contribute to the success of a mission. Therefore, a more holistic approach to selection might be necessary, one that values not just technical expertise but also emotional intelligence, creativity, and adaptability. Ultimately, the goal is to create a team that is not only capable but also resilient and cohesive, ready to face the unknown challenges of space exploration together. Section 6. Cosmic Morality. Ethical Considerations in Interplanetary Colonization. The discovery of habitable exoplanets, planets beyond our solar system capable of supporting life, raises profound ethical questions about the very act of colonization. Do humans have the right to claim ownership of other worlds, potentially displacing or even harming indigenous life forms? The history of colonialism on Earth is rife with exploitation and violence. As we venture into the cosmos, we must learn from our past mistakes and approach colonization with a deep sense of responsibility, respect, and a commitment to peaceful coexistence with future generations. Section 8. The Final Frontier Within Psychological Impacts of Leaving Earth. Leaving Earth would be not only a physical journey but also a profound psychological one. Astronauts would face the challenges of isolation, confinement, and separation from loved ones, all while adapting to the unfamiliar and potentially hostile environments of space. The psychological toll of space travel could be significant, requiring extensive psychological screening, preparation, and ongoing support for astronauts. Understanding the long-term effects of space travel on the human psyche is crucial. both for the well-being of astronauts and for the success of future interstellar missions. Section 9, A Galaxy for All, championing inclusivity in space travel. As we venture into the cosmos, we must ensure that space exploration is inclusive and representative of all humanity. This means actively combating historical biases and systemic barriers that have often excluded marginalized communities from STEM fields and space exploration. We must strive to create a future where space travel is accessible to people of all backgrounds, regardless of race, ethnicity, gender, sexual orientation, disability, or socioeconomic status. A truly inclusive space program will not only be more just, but also more innovative and successful. Section 10. Technology's promise ensuring equitable access to the cosmos. Technology played a pivotal role in making space travel a reality. As we develop more advanced technologies such as warp drive, we must ensure that these innovations benefit all of humanity, not just a select few. This requires a commitment to equitable access to education, training, and resources, empowering individuals from all walks of life to contribute to the future of space exploration. It also demands responsible and ethical development of space technologies, ensuring that they are used for the betterment of humanity and the preservation of our planet. Section 11. One Planet, One Future, the imperative of global cooperation. Perhaps the most critical factor in navigating the ethical challenges of warp drive technology and space travel is global cooperation. No single nation possesses the resources or expertise to undertake such an endeavor alone. International collaboration is not just desirable but essential. It will require open sharing of knowledge, resources, and a shared vision for the future of humanity among the stars. The pursuit of space exploration has the potential to unite us as a species, reminding us that we are all crewmates aboard Spaceship Earth, sailing together through the vast cosmic ocean. Look up at the night sky. What do you see? Is it just a canvas of darkness dotted with tiny specks of light, or is it something more profound, more awe-inspiring? A smattering of stars, perhaps the moon, a faint band of the Milky Way. These are the sights that have captivated humanity for millennia, inspiring myths, legends, and a relentless quest for knowledge. Now imagine peering deeper, past the familiar glow of our celestial neighborhood. Beyond the stars we see with the naked eye lies a universe teeming with wonders, waiting to be discovered. Out there, billions upon billions of stars blaze across the vast expanse of space, each a sun potentially harboring its own family of planets. These stars, each with their own unique characteristics, form the building blocks of galaxies, the grand structures of the cosmos. The universe beckons, a tapestry woven with mysteries waiting to be unraveled. Nebulae, the birthplaces of stars, glow with vibrant colors, while black holes, the enigmatic remnants of massive stars, challenge our understanding of physics. Yet, the distances are staggering. The cosmic speed limit a frustrating barrier to our insatiable curiosity. The vastness of space is both humbling and daunting, a reminder of our small place in the grand scheme of things. A journey to the nearest star, even at the speed of light, would take generations. This immense distance challenges our current technology and understanding, pushing us to innovate and dream of new possibilities. But what if we could cheat the cosmic speed limit? What if the barriers that seem insurmountable today could be overcome with the advancements of tomorrow? What if we could fold space-time itself, creating shortcuts across the universe? This concept, once the realm of science fiction, is now being seriously considered by physicists and engineers. This is the tantalizing promise of warp drive, a technology that could transform us from passive observers to intrepid explorers of the cosmos. Imagine a future where humanity can traverse the stars, uncovering the secrets of distant worlds and perhaps even encountering other forms of life. The possibilities are endless. Advanced civilizations, alien landscapes, and futuristic cities on other planets could become a reality. Our understanding of life, the universe, and our place within it would be forever changed. As we stand on the brink of this new era, the dream of exploring the cosmos is closer than ever. Human colonies on Mars, space habitats, and humans working in space are no longer just the stuff of dreams, but are becoming tangible goals. The next generation of explorers is already being inspired. Children looking at the stars, educational programs about space, and young scientists are all part of this grand journey. They will be the ones to take the next steps, to push the boundaries of what we know and venture into the unknown. In research labs around the world, scientists are working tirelessly on space technology and innovative projects. Their efforts are paving the way for a future where space travel is not just a possibility, but a reality. Space missions are being planned, astronauts are training, and spacecraft are being launched. Each step brings us closer to the stars, closer to understanding the universe and our place within it. As we look to the stars, we are also reminded of the beauty of our own planet. Earth, seen from space, is a fragile oasis in the vastness of the cosmos. The interconnectedness of life on our planet is a testament to the wonders of the universe. The journey to explore the universe is not just a scientific endeavor, but a deeply human one. It is a quest for knowledge, a search for meaning, and an exploration of our own potential. As we reach for the stars, we are also reaching for a deeper understanding of ourselves. The universe is a vast, wondrous place full of mysteries waiting to be discovered. As we gaze up at the night sky, let us be inspired by the possibilities that lie beyond, and let our curiosity guide us on this incredible journey of exploration and discovery. Imagine a vast sheet of rubber, a simple yet profound analogy that helps us visualize the complex nature of our universe. This sheet represents the fabric of space-time, the very essence of our cosmos, where every star, planet, and galaxy resides. 2 points on opposite ends of this sheet signify distant stars, separated by light years, a distance so vast that it boggles the mind. Traveling conventionally across this sheet, even at the speed of our fastest spacecraft, would be a journey of eons, a trek that would span generations. But what if we could pinch the sheet, bringing those 2 points close together, effectively shrinking the distance between them? This, in essence, is the principle behind warp drive, a concept that has fascinated scientists and science fiction enthusiasts alike for decades. By manipulating spacetime, we could create a warp bubble around a spacecraft, a protective envelope that allows it to traverse the universe in ways previously thought impossible. This bubble would compress space in front of it and expand space behind it, creating a wave that the spacecraft could ride. The ship itself wouldn't move faster than light within the bubble. Rather, it would remain stationary relative to the bubble, which moves through spacetime. Instead, it would ride a wave of distorted spacetime, effectively taking a shortcut across the universe, bypassing the conventional limits of speed and distance. Warp drive is still firmly in the realm of theoretical physics, a tantalizing possibility that challenges our current understanding of the laws of nature. However, the possibility, however remote, of bridging these unimaginable distances has captivated scientists and dreamers alike, inspiring countless hours of research and speculation. It represents a quantum leap in our understanding of the universe and our place within it, a bold step towards a future where the stars are within our reach. Imagine a future where humanity is no longer confined to our solar system, where we can explore distant galaxies and uncover the mysteries of the cosmos. With warp drive, the dream of interstellar travel becomes a tangible goal, opening up possibilities for colonization, resource acquisition, and the discovery of extraterrestrial life. This technology could unite humanity in a common quest for knowledge and exploration, transcending borders and bringing us together as a species. The promise of warp drive is not just about faster travel, it's about expanding our horizons, pushing the boundaries of what we know, and inspiring future generations to reach for the stars. As we stand on the brink of this new era, the promise of warp drive beckons us to dream bigger, to strive harder, and to never stop exploring the vast uncharted territories of the universe. The stars have always called to us, and with warp drive, we may finally have the means to answer that call, embarking on journeys that were once the stuff of dreams. The promise of warp drive is a testament to human ingenuity and our unyielding desire to explore, to understand, and to push the boundaries of what is possible. As we continue to unlock the secrets of the universe, who knows what other wonders await us just beyond the horizon? The journey to the stars is just beginning, and with warp drive, the possibilities are as infinite as the universe itself. The concept of warp drive may seem like pure science fiction, but its roots lie in Einstein's theory of general relativity. This groundbreaking theory, proposed in 1915, fundamentally changed our understanding of the universe and the way we perceive gravity. Einstein revolutionized our understanding of gravity, describing it not as a force but as a curvature in the fabric of space-time caused by massive objects. This was a radical departure from Newton's classical mechanics, which had dominated scientific thought for centuries. Picture a bowling ball placed on a trampoline. The ball creates a dip in the fabric, and if you roll a marble nearby, it will curve inward, drawn by the depression. This simple analogy helps us visualize how massive objects like planets and stars warp the space-time around them. Similarly, massive objects like stars and black holes warp space-time around them, influencing the trajectory of light and other objects. This phenomenon, known as gravitational lensing, has been observed and confirmed by astronomers, providing strong evidence for Einstein's theory. Warp drive exploits this very principle. By generating a localized distortion of space-time, we could in theory create a warp bubble that propels a spacecraft through the cosmos much like a surfer riding a wave. This concept was first proposed by physicist Miguel Alcubierre in 1994, who suggested that a spacecraft could achieve faster-than-light travel by contracting space in front of it and expanding space behind it. Alcubierre's warp drive theory relies on the existence of exotic matter with negative energy density, a hypothetical substance that has yet to be discovered. Despite this, the idea has captured the imagination of scientists and science fiction enthusiasts alike, inspiring countless stories and research projects. While we are still far from achieving warp drive, ongoing research in theoretical physics and advancements in technology continue to push the boundaries of our understanding. The dream of faster-than-light travel remains a tantalizing possibility, one that could revolutionize space exploration and our place in the universe. As we continue to explore the cosmos, the principles of general relativity and the concept of warp drive remind us of the incredible potential of human ingenuity and the endless possibilities that lie ahead. The journey to the stars may be long and challenging, but with each new discovery, we move one step closer to unlocking the secrets of the universe. So, as we look up at the night sky and dream of distant worlds, let us remember that the foundations of these dreams are rooted in the brilliant minds of scientists like Einstein and Alcubierre. Their work continues to inspire and guide us as we strive to turn science fiction into science fact. One of the biggest hurdles to realizing warp drive lies in the staggering amount of energy required to warp spacetime. Calculations suggest that creating a warp bubble would require an energy density equivalent to the mass energy of Jupiter, or even a small black hole. Harnessing this energy is a challenge of unimaginable proportions. Current energy sources are woefully inadequate, and even hypothetical concepts like antimatter annihilation fall short of the mark. However, scientific progress often defies expectations. Just as nuclear energy was once considered the stuff of fantasy, breakthroughs in our understanding of exotic matter and energy manipulation could one day unlock the key to powering warp drive. The successful development of warp drive would be nothing short of revolutionary, ushering in a new age of cosmic exploration. We could finally break free from the shackles of our solar system and venture out to touch the stars, unraveling the mysteries of the universe firsthand. Imagine studying black holes up close, witnessing the birth of stars in distant nebulae, or even encountering other intelligent life. Warp drive would not only expand our physical reach but also fundamentally alter our understanding of our place in the cosmos. The implications extend beyond scientific discovery. Interstellar travel could provide new resources, alleviate overpopulation on Earth, and offer humanity a chance to spread its wings and secure its future among